Hey guys, in this video we're going to look at the solutions to the liberal arts math test, the Unit 9 practice number 1, and we'll just go through these problem by problem. So in number 1 it says to find another name for plane P, and so we can name a plane by this nice little script P right here, which is kind of hard to write for people. So we just need another name for plane P. You need 3 points on the plane that are not on the same line. So there's actually going to be several ways you could do this. You could do ADF, you could do AGF, you could do DGF, but the only ones you can't do is you can't involve B because B is not on the plane. And you can't just list these 3 because they're all on the same line, because there could be another plane with those 3 points on it, maybe slanting downwards through it. So one way to do that would be plane, and I'm just going to say ADF, ADF. So we want 3 non-collinear points, not on the same line, but are in the plane. Number 2, if line segment AE is equal to 4x, AF is equal to 5x minus 2, and EF is 6, and E is between A and F, then what does x equal? First thing we need is probably a diagram. So I'm going to draw a diagram. And we're going to put 3 points on it. AE is 4x, AF is 5x minus 2, EF is 6, and E is between A and F. That means that E is between A and F. So A and F are at the endpoints, and E is right in the middle. Now, it says that AE is 4x. So here's AE, so I'm going to label that as 4x. It says AF, the whole thing, is 5x minus 2. So now I'm going to go like this, and I'm going to call AF, all of this, 5x minus 2. Now it says EF is 6. So I'm going to put a 6 right there for EF. All right, it's wondering what x is. If you want to try and figure out what x is, the whole is equal to the sum of these 2 parts. So the whole thing, 5x minus 2, is actually equal to the sum of these 2 parts, which is 4x plus 6. So it really turns out to be an equation with variables on both sides. Pretty simple. Subtract 4x, 5x minus 4x is 1x, minus 2 is equal to 6. Add 2 to both sides, and it looks like x is going to be equal to 8. So actually, it looks kind of difficult at the beginning, but once you set it up and draw a diagram, it's really not that bad. And drawing diagrams is part of this. Number 3, you have, it looks like, a pair of vertical angles, and we know that vertical angles are congruent. So we're going to set those 2 equal to each other. 12x plus 4 is equal to 13x minus 9, and we're going to solve. And we're setting them equal to each other because they are congruent. They're a vertical pair. Vertical pair. So I'm going to subtract 12x on both sides. 4 is equal to x minus 9. Add 9 to both sides. And 9 and 4 make 13. And so now I know that x is 13. For number 4, these are not a vertical pair. They're right next to each other and they're on the same line. So we call that a linear pair. Well, we know for a linear pair that if we add them together, they equal 180. So that's what we're going to do. 15x plus 5 plus another 2x plus 5. All of that together is equal to 180. So we're going to go ahead and combine like terms on the left side. So 15x and 2x make 17x. 5 and 5 make 10. Is equal to 180. Subtract 10 on both sides. 17x is equal to 170. So if we divide by 17, we're going to get x is equal to 10. Okay, number 5 says to name the angle pair 6 and 2. So here's 6, and here's 2. And if you look at your names of those angles for parallel lines and transversals, those are called alternate exterior angles. alternate because they're on either side of the transversal, and exterior because they're on the outside of the parallel lines. So alternate and exterior. Okay. Number 6, if measure of angle 5 is 50, then what's the measure of angle 2? What I like to do here is I like to start labeling all of my angles to see how many of these are actually equal to 50, since 5 is 50. So I'm going to put a 50 right here. Now 7 is a vertical pair, so that's 50. 5 and 3 are corresponding, so 3 must be 50. And we also know that because these are alternate interior. If 3 is 50, then 1 is 50. And then 1 and 7 are also corresponding and they're congruent. So all 4 of these are 50. All the other ones have to be supplementary. So 130 for all the other ones, because they have to add up to 180. 130, 130. All right. So now we want to know the measure of angle 2. Well, the measure of angle 2 is all the way down here. That's 130. 130 is our final answer then. All right, on the back side, this one we have an exterior angle and 2 remote interiors. So we know that the exterior angle, 135, is equal to the sum of these two, 81 plus x. And so now we just need to take 135, subtract 81, and it looks like we get 54. So that's it. X is 54, and that's done. Okay, number 8, we have these two angles here. And there's many ways you can do this. One way is to look at this 135 down there, and since these are vertical, this is 135 also. Well, these are consecutive interior. We know that consecutive interior angles are supplementary. So we're going to have to take those two, 7x plus 3, add it to 135, and set that equal to 180. Now the other thing a lot of students are going to do is set these equal to each other, but these are definitely not congruent. You can clearly see that this one is smaller than this one. This one's much larger. So if you set them equal to each other, you're going to get an answer, but it's going to be wrong. There's only one time when it's going to be right, and then that's if they're both 90 degrees. And they're not. Well, it doesn't look like it. So I have 7x plus 135 and 3 is 138 is equal to 180. So I'm going to take 180 and subtract 138, and I get 42. So 7x is equal to 42. I'm going to divide by 7, and x is going to be equal to 6, and that is what I'm asking for, x. Number 9 says, what's the sum of the measures of the interior angles of a convex polygon with 19 sides? So we need the formula S is equal to 180 times n minus 2. N is the number of sides, and S is the sum of all of the interior angles. So we're going to plug a 19 in for n, and then simplify. So we want 180 times 19 minus 2, which is going to be 180 times 17, and whatever that turns out to be, 180 times 17, 3060. So 3060 degrees is the answer for the sum. And number 10, you have a 1, 2, 3, 4 quadrilateral because it's got 4 sides. We know already from class that the sum of the measures of the angles of a quadrilateral is 360. So I want all of these angles to be equal to 360. And if you didn't know that that was 360, you could just use this formula up here. Again, just plug a 4 in for n, and you're going to get 360. So now I'm going to go around the figure, and I'm going to add them all together. X plus 120 plus 64 plus 131. All 4 of those is equal to 360. So I'm going to add all 3 of these together. So 120 plus 64 plus 131 is 315. So x plus 315 is equal to 360. I'm going to subtract 315 from both sides. So 360 minus 315, and we get 45. So the missing angle measure has to be 45. All right, guys, those are all 10 problems on Liberal Arts Practice Test number 1 for Unit 9. Remember to like my videos, subscribe to my channel if you haven't already, and we'll see you guys later. Bye.